classes. We'll see here why we should create classes and the syntax we can use to do so. Now I have here a program called packages.py whose goal is to really track packages we're sending between different users that we have. I have here a list called packages, and notice how it has two packages represented as strings inside of it. I have one, package 1, Alice to Bob, 10 kilograms, and another one, package 2, Bob to Charlie, 5 kilograms. So two different packages here inside of my list. Now, there are a few different reasons we probably don't want to be using strings to represent these packages here. Now, one of them is strings are flexible, but arguably too flexible. I could very easily change the ordering that I have for each of these pieces of information about a package. Here, I did follow this same pattern of maybe package, number, colon, sender, and then recipient, comma, weight, but I could very easily stray from that as I add more and more packages. I might want something that's a little more rigid, can store information in a better way. So thankfully, I do have at my disposal this thing called a class. Now, a class operates a bit like a template that I can use to create various objects in my code. I could think of each of these packages as being some object. In fact, I could literally look in the real world and see a package as some object. And I could think of my class as being a template to later create some object that looks a lot like a package, but a particular package. So here, I have some pieces of information about this package I probably want to encapsulate, to put inside my template. One might be the ID of the package. Is it 1, 2, 3, some unique ID to refer to it later on. I might also want to store the sender of the package, as well as the recipient, alongside of the weight as well. So classes, these templates, allow me to encapsulate this information in a single place and not worry about all this different formatting that I have to maintain consistently in my code if I were to use something like a string, for instance. So to create a class, to create this template for a package, I could literally type class, just like this, followed by the name for my class, in this case, package. And by convention, these class names tend to begin with uppercase. So here we have capital P, package. And I could later on fill in this package. But here I'm getting started on creating this template for some package that I can then use later on to create particular packages. So let's think about what a template for a package might ideally store. Well, to do so, I need to first create this particular method, one called dunderInit, which allows me to use my template, my class here, to later on instantiate or create some particular object from this template, from this class. So here, I'll define, in this case, dunderInit. Dunder stands for these double underscores here, and it turns out that this, by convention, must take at least one argument, one called self. When I create, later on, a new object, this self refers to the instance, that new object I'm creating, when I were, for instance, to call something like package. We'll see that later on. The other thing this really wants to probably take as input here is all of the pieces of information I need to create some new package. Well, we said down below we want to encapsulate or really combine a few different pieces of information. One is the package ID, one is the sender, and one is the recipient, and one is the weight of the package here. So I could go ahead and say as input to this particular template that I have here, creating some new object later on, I'll go ahead and say each package has a number or some ID. It also has a sender, a recipient, and in this case, a weight. And this is my dunderInit method. It allows me, in this case, to specify what information I'm encapsulating as part of this template. In this case, all packages have some number, some sender, some recipient, and some weight. Well, now we might see where self comes in. Within this dunderInit method, I could actually go ahead and try to assign to this new instance of my object everything I've passed in down below. I could say self.number equals number, self.sender equals sender, self.recipient equals recipient, and self.weight equals weight. Now, So it might be a little bit confusing at first, especially seeing self and especially having made up some of these actual pieces of information down below, but let's see what it could do for us and maybe walk through what's happening each step along the way. So ideally, I want to rewrite my code on line 10 here. This is not what I should be doing to represent packages, but I do now have this template that I'm able to use to instantiate, to create various objects, in this case, individual packages. Well, down below here, let's try doing just that. I'll remove these strings, and I'll then go ahead and as input to my list, well, I'll create some new package. And I can do so, in this case, by typing my class name, package, followed by parentheses. And now here is where I can actually use those arguments I gave to dunder init. When I use package parentheses, I'm actually, at least on one step of the way, calling dunder init to create for myself some new instance of this template. Well, we said here that this should take, beyond self, number, sender, recipient, and weight as arguments. So I can do this. I could say, well, my first package's number is 1. And it's the sender. The sender is Alice. The recipient, in this case, is Bob. And the weight in this case, will be 10. And so this is the way we've now defined some new instance of this particular class. A given package that has a number 1, the sender Alice, the recipient Bob, and the weight 10 for 10 kilograms. Let's go ahead and add in another package, another instance of this class. I could type package again, and I'll say number equals 2, sender equals Bob. Maybe recipient here was Charlie as before, and the weight of this package was 5. And so this is here our way of representing that second package in our list. And now we have a much more methodical way of storing or encapsulating this information thanks to the class we've created above. But now let's see what this was doing here. We said self.number, self.sender, self.recipient, self.weight. Well, later on, we'll actually see how we can access these things called instance variables, but we'll see that in another short. This then was our short on classes, how to create them, and the syntax to do so. We'll see you next time. Well, hello one and all, and welcome to our short on class methods and class variables. I have here a class representing food, and I want to transform it to represent food as you might think of it in a video game. If you've played games like Mario or The Legend of Zelda, you might know that you as a character get some number of hearts representing your life force. And as you eat food composed of various ingredients, you might gain back some variable number of hearts. So to start, here I have a food class where I'm setting, in this case, an instance variable called ingredients equal to some list of ingredients I pass as input when I first instantiate this class. So down here in main, why don't I try to do that? I'll type mushroom skewer, and I'll say that this is a new instance of the food class where the ingredients, in this case, are equal to 1 mushroom and 1 hearty mushroom, 2 ingredients I could find in the The Legend of Zelda, let's say. I'll go ahead and run python of food.py, and I won't really see anything, but this does help me check to make sure that everything is running okay. Well, we said before that I wanted to make sure that I could represent the number of hearts this food might heal the player. So it might make sense for me to have, in this case, another instance variable, one called hearts, that in this case determines how many hearts this food should heal the player when they eat it. But if I wanted to get more advanced about it, I might say, I want the ingredients to determine the number of hearts that this food should heal the player. If there are more ingredients, maybe those should heal the player more. Or if there are special ingredients, maybe those should heal the player more. So it seems like I need a way to calculate the number of hearts that this should heal the player. Well, I'm kind of talking about a function here. I'm giving as input a list of ingredients and getting as output the number of hearts that this food should heal. But when I think about this function, I don't know if it should belong to any particular instance of my class. In fact, when I think about it, I want that algorithm to be the same across all instances of my food. Of course, depending on the ingredients, the actual number of hearts will change, but the algorithm, the method of calculating how many hearts food should actually heal you in this game doesn't depend on any particular instance. It might just belong to the entire class. Now, this is a great example of a class method. Some functionality I want to belong to the class, not to any one particular instance. So how could I do this? Well, to call a class method, I simply type the name of the class, in this case food, followed by a dot, followed by, in this case, the name of that method. So I'll type calculate hearts as the name of this class method, and I'll pass in as input ingredients, just like this. So now I'm calling this class method called calculate hearts, but of course I haven't defined it yet. I'll go down below and do just that. I'll say let's define ourselves a new function called calculate hearts, and I'll say it takes as input ingredients, just like this, and I'll start defining it in a little bit. Now, this currently looks a bit like an instance method without the self that is implicitly the first argument of all instance methods. So how can we turn this into a class method? Well, there are two things we need to change here. First, we need to decorate this class with this decorator at class method. This is a special keyword, really more technically a decorator, that tells Python this function coming next is in fact a class method. The other thing we have to do is change the implicit first argument. For all instance methods, that argument is self, but for class methods, that argument is, in this case, CLS, something belonging to, in this case, CLS is denoting the class itself. It's kind of shorthand for typing food, if you will. So here I have my class method. It's common across all of my classes here. Common across all my instances, rather. And what I'll do here is I'll start writing this algorithm to calculate the number of hearts this food should heal based on the ingredients inside of it. I'll go ahead and type hearts, and let's say that initially it heals only one heart, just like this. But as I add more ingredients, maybe I'll get more hearts. So I'll iterate, let's say, over the ingredients list for ingredient in ingredients. I'll go ahead and increase heart by 1, and I'll go ahead and return the total number of hearts at the very end. So now, if I go down below and I print something here, I'll say print this skewer heals, and let's go ahead and use an F string to get mushroom skewer dot hearts heals some number of hearts. So let's go ahead and run this now down below, python of food.py. I'll see it heals 3 hearts. Why? Well, in this case, we started with 1 heart. We added in a mushroom, that's 2. Added in a hearty mushroom, that now is 3. So we're now seeing how this method is actually allowing us to set, in this case, this instance variable across our various uses of this class. So what else could we do with this? Well, maybe we could get a little more advanced with our algorithm. We could say something like this. If, let's say, hearty is in this particular ingredient name, why don't we increase hearts even more? Maybe give 2 hearts instead of 1. I'll go ahead and run this down below as well. And now we'll see that it heals 4. Why? Because we began with 1 heart, added in 1 mushroom, that's 1 heart, added in a hearty mushroom, which is 2, and now we're up to 4 as well. So run this down below as well, and now we'll see that it heals 4. Why? Because we began with 1 heart, added in 1 mushroom, that's 1 heart, added in a hearty mushroom, which is 2, and now we're up to 4 as well. So this is a way for us to, again, have this functionality across different classes. But often, a class method is useful if we try to access or change something about the class within it. And in this case, we haven't really done that yet. So let's also introduce this idea of a class variable. Well, notice here how in my method, I'm starting with some base number of hearts and setting it equal to 1. But in fact, if I want this base number of hearts to be something I could change across all instances of my class, well, it might be a good candidate to be a class variable. Similar in spirit to a class method, a class variable is some variable that is shared across all instances, or in this case, in the class itself. I'll go ahead and say hearts. Let's say base hearts here equals 1. And this is by convention where and how I can define my own class variables, usually above dunder init, and simply by typing the name of the variable and setting it equal to a value. So now, according to this class variable, base hearts, all of these meals should begin with a base number of hearts that is equal to 1. But how do I access this class variable? Well, I can use now this CLS keyword. I could say CLS dot base hearts, where again, CLS is standing in for, in this case, the class itself, food, for instance. So now if I go ahead and run down below, I'll see the same thing, but now I'm making use of this class variable, way to organize my information and say, look, across all of my instances, across all of the food items I will make, the base number of hearts will be 1. All right. What else could we do with this? One thing we could do, another good candidate for a class method, is to give the user some new way of making an instance of your class. So if I go down below, maybe I want to allow the user to simply find some food. They didn't make it from ingredients, they simply found it elsewhere. So I could do something like this, mushroom skewer equals food, but now if I look at my dunder init method to initialize some new instance of this class, well, I actually have to supply the ingredients. I can't leave that blank. If I look at my mushroom skewer equals food, but now if I look at my dunder init method to initialize some new instance of this class, well, I actually have to supply the ingredients. I can't leave that blank. But what I could do is provide the programmer, in this case, another way to make an instance of this class. When I think about that function, because it is making an instance of the class, that seems to be a class method. It is a method that's going to be common across all instances, and it's also one that, in this case, is producing an instance. So it doesn't make sense for an instance to have it. It's actually going to be the output of this function. So let's think about this. What if I made a new class method down below, one called maybe just from nothing, being able to make, in this case, a new food item from no ingredients? Of course, this will take implicitly CLS as the first argument to this class method. And what if I wanted to also say this, hearts as input here? So now, instead of supplying the ingredients and calculating the hearts, a programmer could simply specify the number of hearts they want their food to have and not worry about the ingredients. Well, how could I do this? If I go down below, this function here should return an instance of my class. Well, thankfully, I have access to the CLS keyword, which refers to the class itself. I could say food, a new instance here, is an instance of my food class, but with the keyword CLS, and I'll say ingredients is really just this empty list. At the same time, I will override that instance variable hearts to be whatever the programmer gave as input to from nothing. I will then return this particular instance. So to be clear, what have I done? I've now created in this class method a new instance of my class using the CLS keyword. I've overridden some of the default values that would have been configured otherwise, and I'm now returning that special instance to the programmer. If I go down below, let's try this. I'll try making a new mushroom skewer, this time though, from nothing. But I'll say that hearts is equal to 2. So in this case, I'm again creating a new instance of my class because from nothing returns to me an instance, but I'm now using this class method from nothing and supplying the argument that hearts is going to equal 2. I'll then go ahead and print how many hearts this mushroom skewer heals, and I'll say, look, it only heals 2 because I, again, told it to heal only 2. Hearts. So this shows us here a few uses for class methods and for class variables. Class methods are good for functionality. You want to be shared across all instances of your class. They're good for giving a programmer other ways to make instances of your class. And then, if we look at class variables, these are good for actually embedding information about the class itself and accessing that through the name of the class, not tied to any particular instance of your class. This then was our short on class methods and class variables. We'll see you next time. Welcome to our short on instance variables. In a prior short on defining classes, we saw a way to create a class or a template for a package, one that we called, in fact, package. And down below, we created several instances of that class, of that template, to represent individual packages here. So notice, on lines 11 and 12, I have here some code that defines for me 2 instances of this class that we called package. It's a bit like me creating a template for something called a package, and down below, creating 2 particular packages. Now I did so as follows. I said down below that this first package has a number 1. The sender was Alice, the recipient was Bob, and the weight here was 10. But what actually happens as we call some code on line 11? Well, we said we'd come back to these lines 3 through 6 here. So let's take a look at exactly what's happening. Well, when I run some line of code, like on line 11, I again am creating some new instance of this class I've defined called package. And along the way, thanks to Python, this method called dunderInit is called. Now we said here that it takes as input self, which refers to the new instance of the class that we are creating. And it seems like what I'm doing here is taking in various inputs, like number, sender, recipient, and weight, and assigning them to various attributes or properties of this class, of this instance of the class here. So it turns out that each of these things, self.number, self.sender, and so on, are called instance variables. They're variables that belong to some instance of this class, and they are defined for me whenever I call package down below. So let's look at number, for instance. Number equals 1. Well, I'm now passing in to dunder init this argument number with the value 1. And what happens to that number 1? Well, it actually gets assigned as an instance variable within this instance of the class. So this instance here has a variable called number, and so on for sender, recipient, and wait. But let's see this in action here. I'll come down below and let me try to actually access these instance variables that I claim I set up on lines 3 through 6. Well, I could imagine, let's say, looping through every package that I have inside of this list of packages, maybe printing them out along the way. Well, to do so, I could use a for loop. I want to print for each package I have, so I'll say for package in the list of packages, and then I'll fill this in a little later. Notice first that package will first refer to the package on line 11, and then on the next iteration, the package on line 12. So very simple here. Let's start off by printing something. We could print the package as a whole, but I don't think we get a very good output. What I could do instead is try printing, in this case, something like the instance variable that we called number, just to start with, package.number. So if I want to access an instance variable, I can, in this case, refer to the individual instance of the class, package here, followed by dot, followed by the instance variable's name, just like we set up above, in this case, number. So if I try this, I'll try Python of packages.py, hit enter, we'll see 1 and 2. But just to hammer this home, let me try instead 1 and 3, and now we'll hopefully see 1 and 3. So it does seem, as I defined in dunder init, that the input to these various parameters of package, these arguments here, they actually get assigned as instance variables of each instance of my class. Now, let's try accessing more and maybe printing these packages in a prettier way. So here, I can do this. I can go back to the format I had before, but now use a Python f string in the package's instance variables. I could say package and then package.number, just like this. If I were to run this, I could see package 1 and package 2. Pretty good. What if I tried maybe the same format from before? I could try colon, and then I could enter in, let's say, the package's sender to package.recipient. And let's see what we see here. Python packages.py, package 1, Alice to Bob, package 2, Bob to Charlie. And this is all happening by accessing these instance variables that I set up in dunder init as well. Let's now add in the wait. I'll say comma, package.wait, and we said the wait was, in this case, in kilograms. I'll go ahead and now try to run this again. I'll go ahead and go back to my terminal, Python or packages.py, and we'll see a much prettier way of formatting these individual packages. In fact, we get the benefits of the strings we saw, let's say, in the short on defining classes, which allows them to be more prettily printed, but we also get the benefits of this class here. So we have encapsulating information now using these things called instance variables. This then was our short on instance variables, and we'll see you next time. We've seen in prior shorts on defining classes and instance variables ways to define some template for some object and ways to instantiate individual instances of those templates to refer to in code and access their various instance variables or traits of each of those individual, in this case, packages. So we have here again a class called package that encapsulates some information about packages in general. We say that every package we'll create will have a number, like an ID, a sender, a recipient, and a weight to it. And we then define here the various instance variables whenever we create a new instance of this class. Down below, on lines 11 and 12, we actually create these instances. We have here, on line 11, a package whose number is 1, whose sender is Alice, whose recipient is Bob, and whose weight is 10. And then finally down below on line 14, we have some code here that actually accesses the instance variables to print out in a more pretty format the package information itself. So let's try running this and see the output down below once more. I'll run Python of packages.py, and we'll see, thanks to the code that we all have here, we're able to print information on these packages while still encapsulating or combining the information in a more organized way. Now it turns out that I can use classes to not just encapsulate or combine pieces of information, but to also encapsulate functionality that I want to be common across all individual packages. And I can do so by defining, in this case, what I might call an instance method, a method that can be run on any instance of this particular class. Now, when I say method here, I'm really referring to a particular kind of function that is part of a class. And I want to show you one that you might find handy, one called dunderstr, dunderstr. So similar to dunderInit, dunderstr is a special instance method that can be called if I were to print some package. Now, down below here on line 15, this is a long line of code, but wouldn't it be nice, let's say, if I could simply print a package like this, print package, and get, let's say, the same format I have down below. Right now, this will not be the case. If I run python of packages.py, I'll see this, which is not very pretty at all. But I could add an instance method called dunderstr to actually improve the output of, in this case, what I see when I call print on any given instance of my package class. So let's go back up here, and to define some new instance method, well, I can simply drop down a line and define some new function that's part of my class. And because this one is a special method defined as some special functionality by Python itself, I'll use these double underscores and then str. In fact, the double underscores, which pronounces as dunder, they tend to refer to these special methods that Python attaches some special meaning to. In this case, dunderstr is actually called every time I call print on an instance of my individual package. So by convention, dunderstr takes as input, in this case, the instance of the class itself that we refer to as self. And within dunderstr, I can return some string that will be printed every time I call print on an instance of the package. So just as a test here, why don't I say this is a package. This is a package. So every time I call print on a package, hopefully I'll see this is a package. I'll go ahead and run Python of packages.py. And for both of those, within my list here, this package and this package, we'll see this is a package, which is helpful, but only a little bit. Like ideally, I'd show some information on the actual instance of the package I'm talking about. So to do so, I can again access these instance variables and return, let's say, something like an F string. It's in the same format we had down below. I could say package again, and then self.number, colon, maybe self.sender to self.recipient, and then comma, self.weight, kg, just like this. So this is the same F string we had in that for loop, but now I've encapsulated that same F string inside of my package class within this instance method called dunderstr. Now, ideally, when I run Python of packages.py, we'll see some more information on this package, but much more simply now, we can simply call print package. I'll run this, and we'll see that same information now part of some instance method called dunderstr. So pretty handy here. Now, what else could we actually use instance methods for? Well, we want to maybe attach functionality that seems pretty core to the idea of being a package. Maybe one thing we want packages to be able to do is calculate the cost of shipping them. So I could imagine here defining another instance method, maybe one called calculate cost, that allows a package to figure out how much it costs itself to ship. So I could define here maybe a new method called calculate cost. And these instance methods, by default again, take as input, as the first argument, the instance itself that we refer to as this variable, this argument called self. Now, as another input to calculate cost, maybe the cost changes, and maybe a cost per kilogram that I could specify as input to this particular method here. I'll type a colon, and within this particular function body, I can then define this instance method called calculate cost. Let's first see how to use this instance method, though. Maybe instead of going down here and just printing the package, I could do something a little more fancy. I could say, why don't we print the package itself as part of this F string, but then also say that it costs some amount. Now that I have this function called calculate cost that is yet unimplemented, I could use it as follows. For each instance, in this case we're calling package in this for loop, I could call calculate cost by typing a dot and then the function, the actual method name. So calculate cost. And now, as input to calculate cost, could I actually type in the input I'm expecting, cost per kg. So I'll say cost per kg, and why don't we say it's about $2 per kilogram to ship some given package. So this is how we want to use calculate cost, but now let's implement it up on line 11. Well, I want to make sure to return here the total cost of the package. I actually know the cost per kilogram. So to do that, I think I just need some simple multiplication. I could maybe find the weight in kilograms and multiply it by the cost per kilogram. So I could say maybe self.weight, again accessing some instance variable, and multiply that by the cost per kilogram. And we'll make the assumption here the user knows that weight should be in kilograms. So we'll go ahead and say this is calculate cost. It takes the weight in kilograms, multiplies it by the cost per kilogram, and that is the cost of shipping this particular package. So let's try it down below. Why don't I go ahead and run Python of packages.py, and now we'll see package 1, Alice to Bob, 10 kg, costs 20, and package 2 costs 10. Probably improve this a little bit. We could maybe add a $sign here to say this is in US dollars, run packages.py again, and now we'll see some pretty good formatting here. So this was our brief foray into instance methods. There are some special ones, like dunder stir, allow us to say how a instance should be printed, as we saw down below. We can also add some functionality, encapsulate functionality, in this case, like one to calculate the cost of shipping some given package. This then was our short on instance methods, and we'll see you next time.